So tonight we are going to look at similarity. So I believe this is just revision. You guys have done this before, and we are just going to revisit some of those main concepts. So I'm going to start off, and hi Watobe, thank you so much. I'm going to start off, and I'm going to just do an example, and you can work with me as we go, and then you're going to have your turn. You'll see Miss Lee's familiar little icons and things here. Like I say, she's left me with strict instructions, so we'll follow her plan for her. Okay. So we've got, first of all, we've got some triangles here, and always what I do when I get a problem like this is I make sure that everything that's written is also on the sketch, because sometimes, you know, it's a bit, they try and be a bit tricksy about it, and they write stuff here at the top of the question. And sometimes you just get going and you jump in and you start solving the question, but some of the information is not always on the sketch. So make sure you read first and then transfer whatever's there onto the sketch if it's not already there. So we're going to start with in triangle PST. So PST is this big one. We have TS perpendicular to PS and RQ perpendicular to PT. Okay, so that's important stuff, and I think we're going to probably need that very soon. So have your highlighters and stuff ready, and especially when you're doing this in the exam or in a worksheet or something, have that ready so that you can fill in all the important stuff that's on the sketch, because geometry is very much a visual reasoning exercise. So if it's in front of you and you can't, and there's just so much going on, the colors will really help you to remember things and to see some of the important information. Right, so everything's there, we're good to go. First question, triangle PRQ, we have to prove is similar to triangle PST. So triangle PRQ, and I'm going to get my highlighter out because there's a bunch of triangles here. So to see which ones you actually have to prove, it makes it easier again if we just highlight them. So PRQ, this one here, PRQ, and PST. PST, so it's the big one. PST. Okay, so I'm also just going to write down over here the two triangles. So we start off in triangle PRQ and triangle PST. So this is how we're going to formulate our similarity proof. For similarity, we need three angles to be equal. So, but luckily, we actually only need to find two, because the third one follows logically from the fact that the triangles in a triangle add up to 180 degrees. So if I start with the green triangle first, and I just look for angles that are going to be equal to the angles in triangle PST. So first of all, we can say that, okay, so here's a right angle. That was given. That's a given piece of information. But from that, I can now say that R1 is also, just get my pen to work, R1 is also 90 degrees because of angles in a straight line. So that's great, because that already gives me one pair of angles. R1 is going to be equal to angle PST over here. So that's 1. So just before you start writing stuff down, just go on like this fact-finding mission of finding things that are equal, looking for the information that you need. And in this case, the information that you need are those two angles. Okay, so we found one, great. The other one, so because the green triangle overlaps with the blue triangle, and they've got this angle here, angle P, that's actually the same angle, it's a common angle. So there's our second angle. All right, so it looks like we've done it. And then the angle that's going to follow from there, just because of the interior angles of a triangle, is going to be Q2 and angle PTS. All right, so let's put all of that down now in our proof. So I'm going to start with angle P, angle T. Let's make it in the, what did we put first? Because remember, when we work with these triangles and similarity, everything has to be corresponding. So I made my green triangle first, and then my blue triangle is second. So my proof can follow that order. So I'm first going to start with angles from the green triangle, and then angles from the blue triangle. It seems a bit finicky, but it really does help to lay out your information quickly and relatively clearly. So we can say angle RPQ is equal to angle TPS. And why is that? They are common. It's a common angle. Or you can just write angle P equal to angle P common, whichever way you've been taught. That's fine. Or you can do it the long way, the way I'm used to doing it, because that's how I was taught. But yeah, it's up to you. Common or common angle is fine. As long as the word
your way is the correct way.
the long way. Okay, now we're going to say about angle R1 being equal to angle TSP. But we have to give a bit of an explanation first. Where did we get that R1 angle from? And we got it from the fact that angle TRQ was given as 90 degrees or perpendicular. The lines were perpendicular, and then we did angles on a straight line. Okay, so that's the other thing with geometry. Geometry, I say, is always a bit like proving a murder, because you have to provide all the evidence. Okay, you can't just say R1's 90 and think that that's enough. Okay, you have to provide the whole story. You have to provide the evidence. So we can say, I'm going to do, let's say, R1. Yeah, R1 is equal to 90 degrees. And why do I say that? Because it's angles on a straight line. And therefore, now you can say, now that you've established that R1 is 90, you can say, okay, so R1 is equal to TSP. Okay, and you don't have to give a reason, because anyone can see that that is 90 degrees and that's 90 degrees. Okay. Could have gone even a step further to say that TSP is 90 because it's given, but that would be a little bit of overkill. Okay, and then the last one that's left is this angle here, equal to that one because of angle sum in a triangle, or angles, yeah, it's angle sum in a triangle. So we can say Q2 is equal to PTS angle sum of triangle, or sum of interior angles of a triangle is also an acceptable reason. Now we end off with stating what we set out to prove. PRQ is similar to triangle PST, and the reason for that is angle, angle, angle. Okay. Right, any questions so far? Anyone have a question or something that's not clear?
Yes, Lysandra's hand is up. Lysandra, you can unmute and put us.
Hi, ma'am.
Hi there.
Ma'am, I just wanted ma'am to please repeat why did you say Q2 is equals to PTS?
PTS, because of angle sum of a triangle. So the interior angles of a triangle add up to 180 degrees, right? So what we've got so far is angle P, where I put the pink dot. Those angles are equal in the two triangles. And then R1 is equal to TSP. Now, because those two angles are already equal, and we know that all the angles in the triangle must add up to 180 degrees, then it follows that the third one is also going to be equal, regardless of what the value is. I mean, we can do a few examples. We can say, what numbers add up to 180, teacher Yolanda? Let's go 30 plus 60. So say I've got triangle 1 and triangle 2, and I know that there's two angles equal to 30 and another one equal to 60. And all the angles add up to 180. So what is this last one going to add up to? It's going to be 90 and 90.
It's going to be the same, yeah.
So whatever your numbers are, if you can prove that two are the same, then the third one is also most definitely. It's just because of the fact that they all must add up to 180.
Okay, thank you, ma'am.
Okay, right. Anyone else?
Nice, Lysandra. That was a nice question.
Yes. It's so often something that people are confused about, so I'm glad people are asking.
Yeah. And take screenshots, please, everyone. If there's no more questions, take screenshots, and then like this, we move on. Y'all are doing an amazing job. I love it. It means you understand, because definitely teacher Miss B will definitely give us some questions. I love it to say Miss B. Will give us questions to do by ourselves. So I hope
yes, it's coming.
Understand. Yeah,
it's coming. Okay, so that's how it always starts off, right? The question will start off, prove the similarity. Then it's going to ask you this stuff here with the colons and the times and the what, and it might look like Greek, but I promise you it's not so bad. Because once you've proven the similarity, the next thing, who knows, who can tell me, what is the next thing that we can conclude? If the triangles are similar, what do we know about the corresponding sides? Can someone put it in the chat for me? If you know. If triangles are similar, what do we know about the corresponding sides? Don't be shy.
let's see some brave soldiers. Remember that there's no ways that you can say an answer and we're like, no, it's fine. Teacher Ma'am B will correct us.
They're not equal. That's right. Well done. They are in proportion. In proportion means that if you divide the sides, you get the same numbers, but we're doing it without numbers, which sometimes, like if you were back in grade 9 and you did similarity, you did numbers. You kept finding sides with numbers, but now in matric, you just do the sides and the fact that they are in proportion. So I don't know, did teacher Lee show you the frog face? Did she show you frog face?
I'm not sure. Maybe I might be the one who is a bad student. Okay, everyone is saying no. So now I don't feel bad
Okay.
anymore. Okay.
Well, here comes the frog face. Are you all ready? So
Yeah, ready, guys. Let's learn this. This is what? It's called what?
the frog face.
Frog face. We are
Maybe
ready.
you called it something else, but I call it the frog face. So once you have your two triangles set up like this, where all the corresponding vertices are in the right order, like you see that P goes with P, R goes with S, and Q goes with T, then you're ready to know which of the sides are in proportion. So we've got triangle PRQ. Let me write this a bit bigger. Triangle PRQ. So when, by the way, just so we're clear, when you get to this question, this is a question about proportionality. It's about the sides being in proportion. It says, prove that the ratio of RQ to PQ is the same as the ratio of ST to PT. So here are my two similar triangles, PST. Okay. Now we're going to set up the sides that are in proportion. So we're going to make one eye of the frog with PR over PS. Those two sides are in proportion. And then we're going to go RQ over ST. That's the other side of eye of the frog. And then we make its mouth. PQ over PT. Okay, so there are your sides that are in proportion, and there's your frog face.
That's awesome to learn it like that.
So you can never ever get it wrong again. Okay, so if you know that your triangle, but this is the important part, your triangle must be, your vertices must be in the right order, things must be in the corresponding order, then you can do this. So PR is equal over PS is RQ over ST is PQ over PT. And if you do nothing else for this question, just write this down, because this is going to be worth a mark, but we have to put a reason. And the reason is that PRQ, triangle PRQ, is similar to triangle PST. Alrighty. So we write that down. The sides are in proportion. Now we are going to look at our actual question. And the first thing we're going to do is see, okay, I need RQ and PQ. But it's a bit awkward with everything written like this as ratios. So let's write them rather as fractions. And you can do that with a ratio. A ratio and a fraction are the same thing. So this is what you need to prove. Okay, so you kind of write it on the side, because you're not writing the answer yet. This is just what you need to get to. So you go where you put all your sides in proportion, and now you look for where, and you get your highlighter out again, and you look for the sides that you need in this answer. It's a bit of a backwards thinking thing. So here we've got RQ, we need PQ and ST and PT. Okay, so here's the ratio that we are going to work with. But we somehow need to juggle it around so that it looks like this. Okay, just want to know if everyone's still with me. Just give me a little thumbs up if you know that, if you understand where we are and what we're doing. And if you're still following, just put a thumbs up in the chat so that I know that you're still there.
Wow.
Good.
My people are geniuses. Nice, guys.
Okay, so you got to take these sides now and move it around to get this. This is what we are working towards. So we're going to take, oh, Tandakile, I see you have your hand up.
Yes, ma'am.
Yes.
Can I ask that angle like look like a triangle, what to call it?
Where?
The angle that is next to PRS, what to call it?
This, the triangle,
Yes.
PST. Yeah, so that's, yeah, it's triangle PST. And then this is for similarity.
Okay. Thank you, ma'am.
Okay. And then there's PQ over PT. So how are we going to get this to look like this, which is what we need to prove? What are we going to do? Any ideas? Anyone? We need RQ over ST, PQ over PT. We are required to prove we're going to cross multiply. Very nice.
Well done, Sibongile. Yes, Sharon. Well
Very
done,
nice.
guys.
Okay, so let's go. RQ times PT is PQ times ST. And then we're going to divide again because we need the PQ at the bottom. So we're going to go RQ over PQ. And then we go ST over PT. And you're done. Okay, so all you need is your frog face, your proportionality statement of the sides that are in proportion, and then you juggle it around with cross multiplication to get to what you need to prove. Okay, we have one more left to do in this question, and then it's going to be your turn. So I'm going to do C over here, and it's basically the same type of question. So now we have to prove that PR times PT is PQ times PS. So you go back to where you wrote out all your sides and you look for the combo that's got those sides in it. PR and PT, there's PR, there's PT, and PQ and PS. Okay, so we're going to work with PR over PS and PQ over PT. PR over PS is equal to PQ over PT. And then again, it's just a matter of cross multiplication. PR times PT is PQ times PS. Right. And that's it. We've proved it. So all these questions just stem from the fact that the sides are in proportion. Alrighty. I'm going to be quiet for a bit and I'm going to head on over. Repeat B. Okay, I'll quickly repeat B. So for B, you start off and you look for, after you've made your statement about your sides that are in proportion, you look for the ratios that have the sides that you require in your answer. So RQ, PQ, ST, PT. So that's what I highlighted in purple here. Those are the sides that we're going to use to get to our final answer. So RQ over PQ is equal to ST over PT. And then we just cross multiplied. First we cross multiplied and then we divided again just so that we can get PQ and ST basically swapped around. Alrighty, let's go off to the next question.
Can they please take screenshots just in case if anyone wants to take a screenshot of what we have done? Yes, please. Thank you. Guys, Miss B is doing it like as if it's like a a packet of chips. The way that I learned, I'm like, whoa, that's amazing. So I hope you guys get it, right? Because she makes it look so easy.
Yeah, it is a challenging section, but I think if you get a few of the basics in place,
Yeah.
then you can definitely attempt some of the easier questions, because these do get very hairy. Like, there's some questions they put on, but recently they've gone gentle with this section in the paper. It hasn't been that bad.
That's nice. At least y'all, when you hear this, you're like, whoo, thank God.
Okay, there you go, guys. I'm going to be quiet for a bit, and then you can try this one.
You know that I make noise every single time. So whenever everything has to be quiet, they just hear my voice. Let's try it. Let's try it, my people. I'm sure we can do it. I mean, I'm like, wow. Now I know exactly which steps I need to do, because she teaches so nicely. So we really need to get this right. How many are we? I think we're 86 of us. So let's all give it a try. And when you get stuck, we are definitely here on the chats. You can ask us and we can direct you. Okay,
Yes.
before we give the final answer.
But give it a proper go, guys.
Yeah.
Give it a good go. And maybe make a quick scribble of the sketch. I know I can't do these things without scribbling and highlighting on the sketch.
I
Makes a
can
big
just
difference.
imagine. Yeah, because you get confused on which triangle am I working in,
Yes.
and you need to know exactly what are you working on. Yeah.
Yeah, no, definitely.
Let's go. I see some really nice focused faces. Okuhle Fodo, okuhle. Are we busy finding a table somewhere where we can sit down and try the examples? Because Miguel there is just walking. I'm watching you. Hi, guys. Ayin, you've been quiet. I hope you're doing well, because I know that, whenever you know things, your hand is up. Whenever you ask, you have a question, your hand is up. So please do feel free. I promise you, Miss B is the coolest teacher ever also. Okay. So don't be afraid. If you don't understand, please do ask. And Okuhle has arrived to her destination, everybody. She's working on it. Let's go. I'm just checking up on Naledi. Naledi, I know you said you arrived a little bit late. I hope you're coping, with doing the example, but we are here to direct you. I under that's okay. You just give it a try, because eventually you will definitely have to go over it. They will have to teach it. There's no way that they will skip it.
Yeah, it has to be done.
Yes, that's the spirit, Naledi. That's the spirit. And Ms. B, just for interest's sake, how many marks would they give for these kind of questions? So it will be like out of what? It's so that we can gauge ourselves to see how many marks we get.
So normally the proof for the similarity is about 4.
Okay.
And then these follow-up questions, depending on the difficulty, it's about 2 each.
Okay.
The geometry section, I think, is 35 marks or 40 marks. So, yeah, in total. And it's it really is the toughest section, because you're at the end of the paper, you're at the end of the exam, and you're tired. And so I sometimes recommend people do this first, because like when they get the paper, actually to do this section first, because you really need fresh eyes. Remember, you can do your paper in any order as long as you indicate clearly your questions. Doesn't matter. You won't get like penalized or anything if you don't follow the chronological order.
Yeah, and I guess especially if you see that there's just these kind of questions that you've already done, and it can catch your eyes that you know how to do it. Like this, you don't try like those ones that are hard and like, oh, you already feel a little bit down. So if you skip around because they give you a chance to check your question paper, you just mark it and say, oh, but this one I can do. Oh, okay, this one I can't do. And then when you start, you just start with this one that you can do. So I think that's a very nice Ooh, Tolele already gave me some of the answers. Okay, let's put if you can tell Miss B on the chat whether you are done or not. So you can just say I'm done, A or B, or just A, B, and C. Like this, she can start and she will know that everyone is done. But Boktolele, well done to you. I see that, and we'll see some, we will correct you just now. But we want to find out how many of you are done so that teacher Miss B and we can continue. So please let us know when you are done on the chat. Nice, Bongenhle. Nice. Can you see, Len? Nice. Okay, let's see. How many of you are done?
Well done.
Nice. That was fast. That was nice. Exactly like 8 minutes.
Yeah. Makopi, you have your hand up. How can I help?
Ma'am, I just arrived right now and I do not even understand anything that's happening here.
Okay, so we will have the recording available afterwards, but just try and follow now as I explain, because this is just like a follow-up from the first one. So it's just a bit more of the same.
Yeah.
Okay. Rightio, guys. Looks like you're done. Most of you are done. So first things first, we check in the diagram PA parallel to BC. You see, there they say it, but they don't show it. So let's put it on our sketch. It's too hard for your brain to try and remember there's a piece of information that belongs over here, so show it on the sketch. And B1 is equal to C, so that's indicated. Nice. I'm going to put some pink there as well so that I just know that it's there. Okay. Now we need to prove that triangle PAB is similar to triangle ABC. So these parallel lines are super helpful because they are giving us some angles that are equal. So we can say that angle A1 is equal to angle A2. And that's because of alternate angles. And that's basically it. Remember, we only need 2 angles. The third one follows because of the sum of the angles being 180 degrees. So that's it. We can do our proof. So we're going to start with triangle PAB and in triangle PAB and triangle ABC. Okay, so I haven't highlighted my triangles, so let's do that as well. So I've got triangle PAB that I'm going to make green, PAB, and triangle BAC, ABC, I'm going to make blue, ABC. There we go. And we can say that angle A1 is equal to angle B2. And the reason for that is alternate angles, and PA is parallel to BC. Don't leave that out. Your reason must be exactly like that. Otherwise, they do penalize for that, unfortunately. And then we've got angle B1 is equal to angle BAC, or just angle C. And that was given. And therefore, the last one we can say is that angle BPA or APB is equal to angle BAC. BAC or A2, and the reason there is angle sum of triangle. Therefore, the triangle PAB is similar to triangle ABC, and the reason for that is angle, angle, angle. They are made of 4. I'm not sure why I did that, but anyway.
Showing that we got 4 marks.
Maybe that's what I was thinking.
Guys. Yeah.
Okay, so let's see. Give yourself a mark for having made this statement somewhere, that those two angles are equal, because alternate. Give yourself another mark for the given, and then for angle sum of a triangle, but the whole line needs to be correct. And then the last one. And then you can celebrate in the chat if you got 4 out of 4, and let us know how you did. We love to know how you're doing.
Sharon just have a quick question on the chat.
Yes. Yeah. Oh, ma'am, if you mentioned that A is common, is it wrong? Yeah, so common angles, like if you compare angle A with what we had here, so this was a common angle. So a common angle is literally they overlap. They're like right on top of each other. Remember, common is also another word for common is shared. So they share the same vertex and they're at the same point. So yeah, so those two angles are not common. And then a common side, so you get common angles, common side. Common sides when they're right next to each other. So we have a common side here with AB. AB is common as a side. Right, I see lots of 3s and 4s, good.
Well done, guys.
Right, now I wonder how many of you did your frog face for the next part.
Sorry, Miss B, we just have Naledi with a question. I'm sure it's based on A.
Yes, let's hear.
Hi, ma'am.
Hi there.
Ma'am, if you said PA is parallel to BC, is that wrong? And you said it's given?
So what we need to state in our proof to prove the similarity are the 3 angles, because what makes triangles similar? The fact that they have 3 angles that are the same. So the parallel lines are there to help us find those equal angles. So in itself, the parallel lines is not a reason for an angle to be equal or for similarity. So always when you write down your proof for similarity, you must be writing about angles that are equal. Does that make sense?
Yes, ma'am. Thank you.
Okay. Rightio. So now we're going to make our proportionality statement here, or our sides are in proportion. So we're going to say that PA over
It's a frog
AB
time.
over AB is AB over BC, and then the mouth PB over AC. Okay, so there we go.
We are all having a
Wonderful.
blast on the chat because we use the frog face.
You should use the frog. You can never go wrong. It will not let you down. Your frog face is your lucky charm going into the exam with you. Okay, so why do we say that? Because not because of that, it's because of the triangles being similar. A, B, C. Okay, so like I said, even if you don't know how to do the rest of the question, just write down that statement because it is worth a mark. And remember to give your reason. Without a reason, no mark. Okay, so let's check. We've got PA and AB and PB and ACO. This one's easy because here's PA and PA and AB, and here's PB over AC. So all we actually, yeah, that's what that is. PA over AB. So all we actually have to do is to take it out of fraction form and put it into a ratio form. So we've already said that they are corresponding, sorry, that they are in proportion. So we just have to put it into the form that the question asks for. So we just write PA to AB is equal to PB to AC. Okay, we got that one right. Put it in the chat so that we can see how you're doing over there. And then lastly, for our last combo, we need AB to AC, AB to AC, AB to AC, okay, and BP to BC. So do you guys see that it's this combo here? Okay, so those are the sides that I need in my answer. So we're just going to need to juggle it around again so that it looks like that at the end. So we've got AB over BC is PB over AC. But what we need is AB times AC. So I think this is just cross multiplying. Okay. Yep, and that's done. You got that one right.
Mrs. B?
Well done, guys. Sorry,
Yes.
someone was asking a question. Solo. Yes.
Please, would you please go up a little? I want to take a screenshot.
Okay.
Thank you.
Well done, guys. I see many of you got it right. Fahim, I'm so proud of you. You got it right. As long as you see the corrections on number A, and I hope that you understand the corrections, right? Well done, guys. That lady also is like, yes, ma'am, got it right. Yes, girl. So 8/8. That's
8 out of 8. Nice.
Win.
Nice.
Wow. Well done, guys.
Okay, I'm just going to scroll to the next for the next screenshot.
Y'all did really, really well. You should feel proud of yourself. Because once it's in here, every single question you do it exactly like this, you win. So far.
Okay, so C, we get AB over BC equal PB over AC. We get that from where we set up our sides that are in proportion using our frog face. And the question asked that we needed to prove that AB times AC is BP times BC. So we can get that if we cross multiply. So that's what we do here. We just cross multiply AB with AC and PB with BC, and then we have what we need.
Nice, guys. Well done. I'm so proud of you.
Okay. I am wondering if we could, yeah, let's see if we can squeeze in one more.
Okay.
What do you think, Miss Yolanda?
Yeah, that will be perfect. Yeah.
Okay. So PB is a tangent to circle ABC. I think this one we must just all do together. So you can think with me as we go. Just gonna make it a bit bigger. Okay. So we have to prove, you see that the questions follow all the same order, prove the similarity, and then stuff with the sides.
Yeah, with the proportion, and then either as the division or the multiplication. I mean,
exactly. Wow. Yeah. So first of all, we've got some parallel lines here. Nice. That's always useful. It almost looks exactly like the previous question, but I think it's a bit different. So we can already say that A1 is going to be equal to B2 because of the alternate angles. And then the other piece of information here is that PB is a tangent to the circle. So by the way, that's also how it's asked. Our knowledge of circle geometry gets mushed together with similarity, and it just becomes one big mush of geometry stuff put together. Okay, so the next thing we can say then, if PB is a tangent, then this angle B1, the angle between the tangent and the chord, must be equal to angle C. And we've got 1, 2 angles. That's enough. And we can prove our similarity.
wow, this just shows us how much you need to know your rules, because I was a little bit like, whoa, okay. But now I understand. Wow. Sure.
Yeah, it all becomes sort of integrated. I mean, matric is the culmination of 12 years of school, so it's no surprise that everything gets mushed together at the end.
Yeah, that's true. That's actually true, that you need to remember everything that you did in grade 8.
Yeah. Okay, so in triangle PAB and triangle ABC, we can say that angle A1 is equal to angle B2. And the reason for that is alt angles AP parallel to BC. The tangent, tangekile, is PB. PB is the tangent. Again, you see how important information is written down. So it's important to read that bit at the top. So the second thing we're going to say is that angle B1 is equal to ACB, and that is tan chord. And the last thing we say is our last angle, which is angle P, is equal to angle A2, and that is angle sum of triangle.
Wow,
have a
it is
question.
repeating and repeating. Yes, I think
Yes,
it's solo again.
Please repeat the second reason. Why is it equal to tan chord? Why is the reason tan chord?
okay, so here's our tangent, PB, and the rule says the angle between the tangent and the chord is AB. So this angle here is equal to the angle in the opposite segment. So you go between the tangent and the chord, and then you jump across to the angle in the opposite segment, which is also on the circumference. So it must be C.
Thank you.
Okay. Okay, and then PA to AB. So we can do triangle PAB. I think we might only have time for this last one. And triangle ABC are now similar. Oops. Yeah. And it's angle, angle, angle. And then if you make a frog face, PA over AB is equal to AB over BC, PB over AC. Okay, so we can see that this question here, question B, PA to AB is AB to BC. So that's going to be this combination here. Let's just write our reason as well. Triangle PAB similar to triangle ABC. But we have to put it into the ratio form. So we just go, we don't even, for this one, we don't even need to cross multiply. So it's PA to AB is equal to AB to BC. But you have to give it in the form that it's asked for, which is in ratio form. Okay, guys, we're going to have to end it there. You